Okay, here we go. So stretch. So typically, if we have something that looks like this, we have a horizontal stretch going on, right? Like this 2 is a horizontal stretch. And that means that the mapping notation on this would be x divided by 2 because we do opposite math. And then we don't have any transformations on our y here. We call this a stretch or sometimes a compression. And the reason we call it a compression is because it like shrinks it instead of stretching it. And then we would say by a factor of 2. So the reason we use the terminology factor of 2 is because we have an actual 2 like in the notation, but what we're doing is dividing by 2, so it kind of gets complicated to say stretching 2, right? So we refer to it as a factor of 2. Okay, so that's all well and good, but it can get a little more complicated. Okay, so sometimes they look a little more complicated. So if we had something that was like this, let's say we have 2x plus 8 squared. So if we looked at this, we would know that we've got a horizontal stretch and a horizontal translation, but it isn't what it seems. We do have those 2 transformations, but that 8 isn't really an 8. And the reason is that we need to factor first. So whenever you have horizontal stretches or reflections, you need to make sure you factor first. But you're going to factor within the brackets. So the brackets with the quadratic don't change. But what we are going to factor out, like if you look at this 2x plus 8, what do they have in common? They have a 2. We're going to factor the 2 out, and that's going to leave us x plus 4. So we end up with brackets within brackets, and that's totally okay because we can't factor out of the big brackets because of the exponent. So this 2 is still our horizontal stretch by a factor of 2. So our mapping notation would be x divided by 2. But now it's our translation that's really changed. So our horizontal translation is not 8. It's only a translation of 4. So our mapping notation, opposite math, means we're going to subtract 4 from our x. And then there was nothing happening with our y, so our y we just leave because we didn't have any vertical transformations. Okay, and the other place that this can really become problematic is if we have a negative. So let's say we have negative 3x plus 6 squared. So if you look inside these brackets, we've got, again, a horizontal stretch or compression, a horizontal translation, but we also have a negative, so we have a horizontal reflection as well. If you were to look at that bracket and ask yourself what to factor, the answer would be what? Negative 3, right? So we're going to do this double bracket situation again. So we still have y equals with brackets and an exponent, but we're going to add a second set of brackets and we're going to factor out the negative 3. So your new bracket is going to have x, and then what? You change the sign here because you're going to need a negative 2. So your translation has changed, right? It appeared you had a translation of 6 to the left before, but we actually have a translation of 2 to the right. So the factor really, it's not necessarily the stretch that changes so much, it's the translation that really gets you. So your mapping notation on this would be everything's happening to the x, so you would have negative 3x plus 2 comma y. So it's all happening horizontally with your brackets within brackets. Now, sometimes the problem might be really nice and already be set up in factored form for you. That's great. And we've been using quadratics as an example, but this can for sure happen with radicals. Like you could have something like this also. And in this case, you would still factor it out. You just do that within your radical. You would factor out your 2 and get x plus 4, right? And this would be your horizontal stretch, and this would be your horizontal translation. Remember, brackets aren't always brackets. They can be radicals. They can also be absolute value bars, right? Absolute value bars, they can be like that. It can be cubic. These are the ones you'll see the most, though, I would say, are radicals and absolute value bars.